Look up at the night sky. Each star is a sun, a powerhouse of cosmic energy. Down here on our pale blue dot, another kind of energy is awakening. It's not born of fusing atoms but of flowing data and intricate algorithms. We call it artificial intelligence, or AI. This isn't just a new gadget or a clever piece of software. It's a fundamental shift in the story of life on Earth. For billions of years, evolution, through natural selection, was the only author of intelligence on this planet. So how do we get from a box of wires to something that can think? The early pioneers of AI tried to do it by hand. They attempted to write down all the rules of human thought. Rules for identifying a cat, for understanding a sentence, for playing a game of chess. Imagine trying to write a rule for every possible situation. If the ears are pointy and it has whiskers and it meows, then it might be a cat. But what if it's a kitten? What if it's sleeping? The task was impossibly complex. The universe of rules was simply too vast. A new approach was needed. One based not on being told, but on learning. This new approach is called machine learning, and it's the engine driving the modern AI revolution. The core idea is beautifully simple. Instead of giving the computer rules, you give it examples. Lots and lots of examples. You don't tell the computer how to find a cat, you show it a million pictures of cats, and you show it a million pictures of things that are not cats. The machine on its own starts to notice patterns. It learns to associate certain clusters of pixels. The curve of an ear, the shape of a whisker, the texture of fur, with the label cat. It builds its own rules. Rules that are often far more complex and nuanced than any a human could write. Let's go back to our cat example. When a neural network sees a picture of a cat, the first layer of nodes might just recognize simple things like edges or colors. The next layer might take that information and learn to recognize combinations of edges like corners or curves. A layer after that might combine those corners and curves to recognize shapes like eyes, ears, and whiskers. Finally, the last layer takes these identified features, eyes, ears, whiskers, fur, and concludes with a high probability, that's a cat.